is thrown vertically upwards with velocity u, at what height will the potential energy equal to kinetic energy? At what height will the potential energy equal to kinetic energy? In this case, we are going to equate the two energy together. Potential energy will be equal to kinetic energy. And the formula for potential energy is mgh. The formula for kinetic energy is half mv squared. You can see m here, m here. It cancels each other. Then, at what height? This is your height h. Will now be equal to, this is going to be v squared divided by 2g. This is what they are asking from you. At what height? And this is the height. You just make your h the subject of the formula, then you have this. That is what they are asking from you. Let's consider question number 9. Question number 9 says, if it takes an object 3 seconds to fall freely to the ground from a certain height, what is the distance covered by the object? We are given the time for the object to fall from that particular height. They say what will be the distance covered by the objects. This is what we are going to do. In this case, we have h is equal to ut plus half gt squared. Before the object is released from that height, the initial velocity is equal to 0. And if it is equal to 0, automatically our u and t, when you multiply u by t and your u is equal to 0, everything becomes 0. Then you are going to have h is equal to half gt squared, which is equal to half. Your g is 10, then you are given time. The time there is 3 seconds. 3 squared, which is equal to, let's look at what I have here, times 10 times 9. 1, 5. And 5 times 9 is 45 meters. That's question number 9. Question number 10. A palm fruit is dropped to the ground from the top of a tree 45 meters tall. How long does it take to reach the ground? Let me give you a note here. In physics, whenever you hear the word how long means time. How far means distance. We are given the height to be 45 meters, and we are given g to be 10 meters per second squared, and we are looking for the time. H is equal to ut plus half gt squared. Before the fruit will fall from that height, before it falls, the initial velocity is equal to what? 0. So u is equal to 0. Then what you are having left is half gt squared. But we have been given the height. The height is 45. Put it there. 45 times 10, then t squared. 2 here, 1, 2 here, 5. 45 is equal to 5t squared. So that t squared is equal to 45 divided by 5. And t squared will be equal to what? 9. Take the square root of 9. Then t is equal to 3 seconds. 3 seconds. How long? And that's what you are told to calculate. Question number 11. A carpenter on top of roof 2 meters high, dropped a hammer of mass 1.5 kilogram and it fell freely to the ground, the kinetic energy of the hammer just before hitting the ground is, in this case, we are going to equate the potential energy to kinetic energy, which is equal to mgh. And the value for the mass of the hammer is 1.5, your g is 10, and the height is 20. If you try to multiply 1.5 by 10 by 20, we have 300 joule. 300 joule. And that is question 11. For question number 12, the question says 2 balls, X and Y, weighing 5 grams and 50 grams respectively, were thrown up vertically at the same time with a velocity of 100 meters per second. How will their position be in 1 second later? Question number 12 says 2 balls, X and Y. 2 balls, X and Y. They weigh 5 grams and 50 grams. This one is 5 grams. This is 50 grams. Respectively, were thrown up vertically at the same time with a velocity of 100 meters per second. They have the same velocity. This is 100 meters per second. This is also 100 meters per second. How long their position will be in 1 second? The time for this is 1 second, 1 second. The same speed, the same time. Then we are now looking for the distance. The distance, we are coming from v squared is equal to u squared minus 2gh. Minus 2gh. We are having minus because it's a motion of a body against gravity. Before the body is being thrown, our initial velocity is equal to what? 0. Then if you are having there, you are going to have v squared, it will be equal to 2gh. Then we are looking for the h, then we are going to have v squared over 2g. And we are given 100, v squared, that's 100 times 100, then 2 times 10. 0 can do 0. 2 cancel this, that's 5. Altogether, we are having 500 meters. So this answer to this question is that X and Y will both be 500 meters from the point of 2. X and Y will both be 500 meters from the point of 2. That's the answer to question number 12. Question number 13. The question number 13 says, which of the following graphs represent motion with uniform velocity? You can see all the graphs. You have A, B, C, and D. Look at this graph. This graph is an example of a motion coming to rest. Let me draw a velocity time graph for you. VT graph. A particle or a body starts from rest and accelerates uniformly. This line we draw to this point, this is what we call uniform acceleration. This is the uniform velocity. This is the uniform retardation. By the time you start from rest, you have uniform acceleration, uniform velocity, uniform retardation. So from this graph now, we can get the answer to this question. This is an example of a retardation. This is an example of a body starting from rest But in this case, this one is not starting from west, but it's starting with a particular time. Okay? But in this case, it's starting with a particular velocity because it's not starting from west, it's not starting from 0. This one, the fourth option is an example of uniform velocity. If you see, this is uniform velocity at a particular time. So the answer to this question is option D. Which of the following graph represents motion with uniform velocity? Is option D, which is the answer. It's not this, it's not this, it's not this, it's option D. And that is the answer to question number 13. Question number 14 says, a stone thrown vertically upwards returns to the ground. Which of the following figures represents velocity time graph? You can see how the figure here. We have a stone, we throw it vertically upwards. The question says, out of all the figures we are having here, which one represents the velocity time graph? By the time you throw up an object, the object is undergoing what we call a retardation. Why? Because as you throw the object upward, the speed or the velocity of the object is decreasing. It's not reducing. But by the time the object is coming down from a particular height, the velocity will increase. So in this case, you are having B as your answer. By the time the motion is coming down like this, it's representing the motion of the object moving upward. Then by the time it's going up like this, then it's representing the motion of the object moving downward. So the answer to this is this. Not this, not this, not this. In fact, this one is representing a retardation. A retardation. So, and all the other ones, this one is representing the motion of an object in a parabolic path, which is a